Hello, students, and welcome to our lesson on factoring, where we will be covering the greatest common factor and factor by grouping. So first, what is factoring? The process of writing one polynomial as a product of two or more polynomials is factoring. This is the inverse or opposite, depending on which word you prefer. But in mathematics, generally we prefer the word inverse. So it is the inverse of multiplying polynomials. You might think that the inverse of multiplying is dividing, and in some cases that is true, but what factoring does is it allows us to divide a polynomial by a polynomial and write both results as a product multiplied together. So in a sense, we're doing division but without throwing away the divisor. We're going to keep both the original polynomial and the divisor all in one piece as a product of the quotient and the divisor. All right, hopefully I didn't confuse you too much with that. All we're doing is doing the reverse process of multiplying polynomials. So for example, we have 2x squared multiplied by 3x squared plus 5x minus 4. If we wanted to multiply these two polynomials, we would distribute the 2x squared. We would get 6x to the fourth plus 10x cubed minus 8x squared. Okay, just multiplying everything there by the 2 and by the x squared. So that direction we just did is multiplying polynomials. Okay, if we wanted to go backwards though, so if we started with the end result and we wanted to go the other direction, so taking the 6x to the fourth plus 10x cubed minus 8x squared and writing it as the product of two factors, then that direction would be called factoring. And so now that we're learning factoring, what's great is that we can check our work for any problem where we were multiplying or factoring problems. Because once you know how to go both directions, you check your work for one direction by going the other direction. So multiplying is the inverse or the reverse or opposite of factoring. So now what does it mean to be a factor of a number or variable? Hopefully you've seen a little bit about factors before when working with numbers. So a number or variable is a factor of another if it divides evenly into it. And by divides evenly, we mean that there is no remainder when we divide. So for example, 12 is our number we're going to start with. 12 has quite a few factors. Okay, if we break down 12, there's a lot of things that divide it. For starters, we can divide any number by 1. So 1 divides 12, meaning 1 is a factor of 12. 12 is divisible by 2, so that means 2 is a factor of 12. 12 is divisible by 3, so 3 is a factor. But then we also have the combination of factors make new factors. So 2 times 3, two of the factors we already have there, 2 times 3 is 6. 6 divides 12, so 6 is also a factor of 12. And the last number that's a factor of 12, everything always has itself as a factor, so 12 is a factor of 12. Where in this case, 12 divided by 12 would give us 1. Notice that is a whole number. So as long as when you divide the original number, you get a whole number, that thing you divided by is a factor. For polynomials, or any real expression, it doesn't look too much different. When we add in variables, the process doesn't change, we just have to keep it general. So for xy squared over there on number 2, our factors are no longer going to have numbers in them. Instead, our factors are going to be the variables that divide xy squared evenly. So for example, xy squared is divisible by x. If I were to divide xy squared by x, I would just get y squared. Xy squared is also divisible by y because there's a y in it. We can also then divide by bigger things. We could divide by x and y at the same time. If we divide xy squared by xy, we would just get y left over. If we divide xy squared by y squared, then we would just get x as our quotient. And lastly, we can divide by the whole thing, xy squared itself. So any piece that evenly divides the original expression is a factor of that expression. So now, what is a GCF? Well, it's the greatest common factor of a set of terms. So up above, we just saw a whole list of factors, but in general, we don't want to write out everything that's a factor. We just want to jump straight to what is the biggest factor. And in general, we want the biggest factor that two or more things have in common. So the GCF of a polynomial is the largest number and or variable or variables, if we have plural, like x and y in the example above. It's the biggest number and or variables that divide evenly into the terms. So the GCF has to divide all of the terms, not just one term. The calculator can find a GCF of a set of numbers for us, but on the calculator, it's actually called GCD. So if you want to use, for example, on Desmos, what you would do to find the GCF of numbers is go to the functions, so where it says function, and then you would click on GCD. So real quick, I can show you. If we pull up Desmos graphing calculator here, and I hit functions, then we can scroll down to where we see GCD. Way down here at the bottom, if you click GCD, then you can type in your two numbers. So example number 3 down there, we're about to use the numbers 27 and 18. So I put 27 comma 18 inside, and it tells me that the GCF is 9. So now I am not going to be using Desmos or any calculator for any of the problems we're doing in this lesson, but it is totally acceptable if you are allowed access to a calculator, which in our course you are, that you use the GCD function here. I highly recommend, though, that for most examples, you do it by hand because, quite honestly, it's quicker to do it by hand than it is to pull out a calculator, but we do have the technology available to us. All right, so that being said, we're not going to use any more calculators in this lesson. For variables, it's actually a lot easier. You don't really have to use any technology ever because all you're going to do is choose the lowest exponent you see with that variable. So let's actually jump to number 4 first real quick, and then I'll go back and show you how to find the GCF on number 3. So for number 4, we have x cubed and x to the 5th. If we were to write out these terms, x cubed is x times x times x, and x to the 5th is 5 x's next to each other. The GCF is going to have to be the biggest number of x's that shows up in both of these. So there's 3 x's in the first x cubed, and there's 5 x's in the second, x to the 5th, but 3 x's is the biggest number of x's that appears in both of them. So we would say that x cubed is the GCF of x cubed and x to the 5th because 3 x's is the highest number of x's I can pull out of each of these. But notice all we did is choose the lower exponent. So whenever you're finding the GCF of the variable terms, you're just going to look for the lowest exponent on that variable. Since 3 was less than 5, x cubed is the GCF of these x terms. All right, so now let's see how it works with numbers. We already saw with the calculator that the GCF of 27 and 18 was 9. The way we can get there by hand, though, is by writing the prime factorization of each number and then just checking what they have in common. So 27 is really 3 times 3 times 3, and 18 is really 3 times 3 times 2. So by breaking down each of these numbers into the prime factorization, all I have to do is see what they have in common. So here, the GCF of 27 and 18 is going to be whatever they have in common, which in this case, notice they both have 2 3's. So 3 times 3 together will give me a 9 as the GCF. So when you are looking for GCFs, really we're trying to find what do the terms have in common. So for numbers, you break it down into prime factors and you see what prime factors they have in common. For variables, it's always going to work out to be whatever the lowest exponent on that variable is. Because notice, the most number of x's they had in common was 3 x's. But we don't need to write out all the x's like that. We can just find the lowest exponent. For numbers, it's very helpful, though, to write out the actual prime factorization and then just see what they have in common. All right, so now how do we factor out a GCF from a set of terms? We just saw how to find a GCF, but how do we actually factor it out? Well, what we're first going to do is, of course, find the GCF using the steps we just did above, and then we're going to write it outside of a set of parentheses. Okay. Then we're going to divide each of the original terms by the GCF we found, and we're going to write the results of that division inside of the parentheses. So on the outside, we'll have our GCF. On the inside, we'll have what we get from the division process. Now, answers can be checked by multiplying or distributing the GCF back into the set of parentheses. But in general, as long as we are going through the process correctly, we don't have a reason to go backwards. So it's nice that we can check every answer, but as long as we're following the correct steps, we shouldn't have to. So it's an option, but we should not have to. Now, the number of terms inside of the parentheses or in the parentheses should be equal to the number of terms that we started with, because we're not getting rid of any terms. We're just factoring a GCF out of those terms. So we should always have the same number of terms in the parentheses that we began with. When the first term of the polynomial is negative, we are going to include that negative sign in the GCF. Just as a general rule of thumb, we prefer that the first term of our polynomials is always positive. So if we factor out a GCF, we want to make sure that that GCF is negative whenever the first term of the polynomial is negative. That way we can turn it into a positive. Right. And then a GCF can be a lot of different things. It can either be a monomial, which is one term, can be a binomial, which is two terms. It could be a trinomial, which is three terms, or it could be actually just any size polynomial. For our examples today, all of them are either going to be monomials or binomials, so one or two terms, but that doesn't have to be true in general. So now let's do a couple examples. Number 5 here, we have 5x cubed plus 10x squared minus 15x. What I always do is start by writing my parentheses, where inside I know that I need to have 3 blank spots because there was 3 original parts to our polynomial. So the number of terms in my answer is always going to line up with how many terms we started with. Now I need to find out what the GCF is. So the GCF is going to be found by finding the greatest common factor of the numbers and the greatest common factor of the variables. I like to start with the variables because it's the easier part in my opinion. So when we look at these terms, we have x cubed, x squared, and x. The GCF will always be the lowest of those exponents. So x to the power 1 over here on the side is going to be the greatest number of x's we can take out. If I take out that x, then I can remove one x from each of my terms that I started with. So by pulling out this x from 15x, that is going to leave me with just 15 in the back, and it's a minus 15 in this case. It's going to leave me with 10x in the middle, because we took only one of these two x's out. And it's going to leave me with 5x squared as our first term, because I took one of the 3x's out to the front. So what I just did is I divided each of these terms by x. But really what dividing by x does is it takes away one of those x's from each of the terms. So now we're going to focus on the numbers. So we're going to do the exact same process, but now we have the variables already taken care of. We just have to focus on the numbers. So when we look at 5, 10, and 15, we need to know what the greatest common factor of 5, 10, and 15 is. That number is going to be 5. The reason I know it's 5 is that I can rewrite each of these numbers as prime factorizations of themselves, where 5 is just 5 times 1, because 5 is already prime, 10 is 5 times 2, and 15 is 5 times 3. So they are all divisible by 5, but that's the biggest number that's going to divide all three. So what I can do is pull a 5 out to the front, and it's going to multiply with the x I already have there. Then on the inside, I am dividing each of these terms by 5. So 5x squared divided by 5 is x squared, 10x divided by 5 is 2x, and negative 15 divided by 5 is negative 3. So that first one I did in 2 steps. Usually we'll just do this in 1 step though. And remember that if you have trouble getting the GCF of the numbers, you can always use the calculator to help you out. But in general, what we're doing is just finding the biggest prime factor that they all have and then putting those together. All right, number 6. We have 24xy to the fourth minus 12x cubed y. So I'm going to start by writing my parentheses, and I'm going to leave enough space inside for 2 terms. Now I want to figure out what variables to pull out. So when I look at the x terms, I have 1x in the first term and x cubed in the second term. The smaller of those is x. So I'm going to pull an x out to the front. When I look at the y's, I have y to the fourth and y to the first. So the smaller exponent is y to the 1. So I'm just going to pull out 1y to the front. When I look at 24 and 12, I need to find the GCF of those two numbers, where 24 and 12 are both divisible by 12. So since 12 is one of the numbers and it already divides both numbers, I can go ahead and say that 12 is my GCF of these two numbers. If you ever want to do that in extra steps, you can take the two numbers, 24 and 12, and make factor trees out of them. So 24 is 12 times 2, 12 is 4 times 3, and 4 is 2 times 2. For 12, same thing, 4 times 3, and 4 is 2 times 2. Then I'm just looking for what they have in common. So they both have a 2, they both have another 2, and they both have a 3. So 2, 2, and 3, if I multiply those together, give me the 12 that I pulled out to the front. Okay, so you can always use factor trees, and you can also always use a calculator to find that GCF. All right, now when I divide each term by 12xy, I divide the numbers and I subtract the exponents on the variables. So 24 divided by 12 is 2. X divided by x just gives me nothing. It gives me a 1. X divided by x is 1, so we have no more x's in that term. And y to the fourth divided by y is y cubed, because we subtract 1 from the 4. Then we have a negative sign. 12 divided by 12 is 1, so I'm not going to write the 1. X cubed divided by x is x squared. And y divided by y, the y's just give us a 1 when they cancel each other out, so I don't need to write a y term. And so I'm going to adjust my parenthesis a little bit here, but our answer right there is 12xy multiplied by 2y cubed minus x squared. All right, now we have a whole bunch more examples for us to try. So we're just going to rapid fire through them. Okay, there are a couple you tries on here, so please pause the videos when you feel comfortable. That way you can give those a chance before I've gone over them. Okay, for number 7, we have 2x squared y squared plus 4xy minus 6x. I have 3 terms, so I'm going to write parentheses with enough space for 3 terms in them. The numbers 2, 4, and 6 are all divisible by 2, but nothing higher. There is an x in all 3 of these, but there is not a y in all 3, so I can't pull out any y's. So I only pull out 2x to the front, that is the GCF. When I divide each term by 2x squared y squared, the 2's cancel. I have 1x left and y squared left. 4xy divided by 2x is going to give me a 2. The x's cancel, and I just have 1y left. And then negative 6x divided by 2x, 6 over 2 is 3. I have my negative sign in front, and those x's cancel. All right, if you haven't paused yet, go ahead and do the you try. Okay, hopefully you paused. I have 3 terms, so I'm going to write parentheses with enough space for 3 terms inside. 24, 18, and 12. 12 is too big. They're not all divisible by 12, but they are all divisible by 6. So 6 is going to be my GCF. And then if I look at the exponents on the a's, 1 is the smallest exponent, so I'm going to use a to the first power. When I divide each of these terms by 6a, I'm going to get 4a to the power 4 plus 3a to the power 2 minus 2, because on that last term, the a's canceled out. Notice that I always, when I pull out variables, have at least one term that ends up without a variable in it. Because by definition, if I'm pulling out the most a's I can possibly pull out, whatever had the least number of a's, I'm going to take all of those to the front, which means there's not going to be any a's left in that 2 term. So whenever you're pulling out a variable as a GCF, that variable will always end up being missing from at least one of the terms. All right, let's go ahead and move on. Number 8, we have negative 4x cubed plus 16x squared plus 12x. Because we have a negative in front, I am automatically going to make my GCF negative. And because we have 3 terms, I'm going to write parentheses with enough space for 3 terms inside. So automatically, I'm pulling a negative out to the front, and then 3 terms inside of my parentheses. When I look at the numbers 4, 16, and 12, the GCF here is going to be 4, because 4 is the biggest thing that divides all 3. And the x's, the lowest exponent on the x is 1, so I'll pull out 1x. Now, we got to be careful because we're pulling out a negative. All of these terms inside are going to change sign. So negative 4x cubed divided by negative 4x is going to give us positive x squared. 16x squared, when we divide by negative 4x, will give us negative 4x. And 12x divided by negative 4x will give us negative 3, where the x's divide out and the sign changes because we divided by a negative. So always be careful when you're pulling out negatives. We're going to see another example in it with number 9 here. Again, because we have a negative in front, I'm automatically going to make my GCF negative. And we have 3 terms, so I'll write enough space in my parentheses for 3 terms. 6, 18, and 6 are all divisible by 6, so that's going to be our GCF number. X squared, x, and x, the lowest exponent there was x to the power 1. Y cubed, y squared, and y, the lowest exponent there was y to the power 1. And so I'm just pulling out a negative 6, an x, and a y. From the first term, the negative 6's will divide and give us 1 in front. X squared over x gives us 1x, and y cubed over y gives us y squared. 18xy squared divided by negative 6xy is going to become negative 3. The x's are going to divide each other out, and y squared over y just leaves us with y to the power 1. Negative 6xy divided by negative 6xy, hey, those are the same thing. So when you divide something by itself, we just end up with a positive 1. The negative signs cancel, the 6's cancel, the x's cancel, the y's cancel. When everything cancels, you don't end up with 0, you end up with a positive 1. Because remember, anything divided by itself is just 1. All right, number 10. We have, again, a negative sign in front, so I'm going to pull out a negative. But if you notice, 5, 3, and 2, well, those are all prime numbers, so they don't have any prime factors in common, and not all of them have an x, so I can't actually pull out anything other than that negative sign. So I'll pull out the negative, and it's going to change everything inside to be positive. So 5x squared plus 3x, and then 2 becomes negative, because everything just changed signs. So I can pull out that negative 1, which is the negative sign in front, but there's not actually anything else to pull out of this polynomial. So all we pulled out there was negative, which changed all the signs, but didn't change anything else about it. Okay, we have another U try, so if you haven't paused, go ahead and give it a chance. All right, we have negative 14x to the 4th plus 21x cubed plus 7x. We have a negative sign in front, so my GCF is automatically going to be negative. I'm going to write enough space for 3 terms. Our GCF of 14, 21, and 7 is 7. And x to the 4th, x cubed, and x to the 1, the lowest exponent there was a 1, so we're just going to pull out 1x. When I divide negative 14x to the 4th by negative 7x, I get positive 2x cubed. Then I get negative 3x squared. And then 7x divided by negative 7x, the negative sign is going to stay in effect, but the 7x divided by 7x is 1, so I end up with just a negative 1 there. The 7's cancel and the x's cancel, but that negative sign did not cancel out with anything, so we're left with a negative 1. Notice the difference between that and problem number 9. In problem number 9, we had a negative 6xy divided by a negative 6xy, So those two negatives gave us a positive. But here we have a positive divided by a negative, so our result is a -1 instead. All right, that was the last of the monomial GCF examples. Now we're going to see what it looks like when we have a binomial as a GCF. So number 11 and number 12, it's going to be a little bit different. Really, it's the same thing, but it just feels different when you're doing it. So for number 11, we have x parentheses x plus 2 plus 7 times another parentheses x plus 2. So I think we can all look at that and see that there is an x plus 2 that shows up twice. That x plus 2 is our greatest common factor. Okay, you need to remember that we have two terms here. We have the entirety of x times, put that a little too high, we have x times x plus 2, and we also have 7 times x plus 2. So we have two terms. I'm going to follow the exact same steps as before, where I'm going to write parentheses with enough space for two terms inside. But then what I'm going to put in front is the biggest thing that divides both of them, which is going to be the whole thing x plus 2. So I put the x plus 2 in front, and then I divide each of the highlighted terms by x plus 2. So when I divide x times x plus 2 by x plus 2, all I'm left with is this x in front. So I just put an x there. When I divide 7 times x plus 2 by x plus 2, all I'm left with is the 7 in front. And so it's a positive 7. So I'll write plus 7 there. So from the first set of terms, or from the first term, I just get this x. And from the second term, I just get this 7. But that GCF of x plus 2 goes in front. So now I wrote a lot of colors and did a lot of underlines there. But in reality, all we're doing is taking the set of parentheses they have in common and putting it in the front, and then taking whatever's left behind and putting it in the back in those second set of parentheses. So in the next one, number 12, we have 3 times 2x minus 5 plus 4 times 2x minus 5. I'm going to write the 2x minus 5 in the front. That is the GCF of these two terms. And what's left behind is the 3x and the 4. So in my second set of parentheses, I have enough space for two terms because we started with two terms. And what we have left is a 3x and a positive 4. So when you actually do it, it's not too complicated, but it looks a little funny. All right, because the GCF is now something big. It's not just a number and a letter. It's an entire expression that we're pulling out to the front. But just recognize that we're doing the exact same process. We're taking the biggest thing that divides both of them and moving it to the front. And then we're taking whatever's left behind, in this case, the 3x and the 4, and we're putting that in the back. All right, so now we're going to do a little factor by grouping. So we have some steps. We are going to use a line. Believe it or not, we're just going to be drawing a line to separate the four terms that were given into two groups of 2. And I should clarify, it says 4 terms because when we factor by grouping, this is going to be when we have 4 terms. Okay, so when we have 4 terms, we can use factor by grouping by drawing a line right down the middle of the problem to separate the 4 terms we're given into 2 groups of 2. We're going to factor out the GCF from each of the groups. Notice it's called factor by grouping, and we're factoring out the GCF from 2 groups of 2. We're going to factor out the binomial GCF that is found in the last step. So we're going to factor out the binomial GCF. And then we're going to write the remaining terms as a product. So the remaining terms will go in parentheses, and this is all going to be a product of 2 sets of parentheses. So what we're doing is we're taking 4 terms that are all written as one polynomial, and we're going to factor by grouping to turn it into 2 factors. All right, so let's do it in number 13. You're going to see it's really just what we were doing before, but we're going to do it in 2 steps. Okay, so step 1 is draw a line down the middle of the problem. So right after the first two terms, I'm going to draw a vertical line. Now, we're going to factor the GCF out of the first two terms, and then we're going to factor the GCF out of the second two terms. So from the first two terms, I'm looking at 2x cubed plus 2x squared. Those have a 2x squared in common, and that leaves behind 2x cubed divided by 2x squared is just x, and 2x squared divided by 2x squared is just 1. So we leave behind an x plus 1. Then we're going to do the same thing for 3x plus 3. 3x plus 3 has a 3 as its GCF. So I'm going to put a 3 out in front of a set of parentheses. And when I pull the 3 out of 3x plus 3, I get x plus 1 again. All right, so now the third bullet point up above should make a little bit more sense. It says factor out the binomial GCF. So we can now see that we have an x plus 1 in both terms of this polynomial. So we're going to pull that x plus 1 to the front, and that leaves behind a 2x squared and a 3 for my second set of parentheses. So we have now taken 4 terms and rewritten it as the product of 2 terms, x plus 1 times 2x squared plus 3. And if you were to distribute the x plus 1, you could get back to where we started, which was a group of 4 terms. All right, number 4. Number 4 has one extra step that was not mentioned yet, which is that we want to have our terms in standard form or descending order. So first step is write in descending order. Okay, if you don't have your terms in descending order, factor by grouping might not actually work out. So the first thing we're going to do is rewrite this as 6x cubed plus 3x squared, where I'm taking the next variable exponent down. So I'm going from x cubed to x squared and just moving it up to the front. Then minus 4x minus 2. So I'm putting the minus 2 all the way in the back because it does not have a variable. Now we're going to follow the same steps as number 13. I'm going to draw a line down the middle of the problem to split it into two groups of 2. 6x cubed plus 3x squared. The GCF is 3x squared. So I'll pull out the 3x squared, which will leave behind 2x plus 1. Then the second set of parentheses, the second group of 2 terms, negative 4x minus 2, there's a negative sign, so I'm going to automatically make my GCF negative, and they're both divisible by 2. So negative 2 is my GCF, and then in parentheses, when we divide both terms by negative 2, we're leaving behind 2x plus 1. Notice that 2x plus 1 is in both groups. So I'm going to pull that 2x plus 1 to the front. That's my binomial GCF. And that leaves behind a 3x squared and a negative 2 in this case. So 3x squared minus 2 is my remaining factor. So again, we've taken 4 terms and factored it into the product of 2 factors. All right, 2 more. 2x cubed minus 12x plus x minus 6. I'm going to draw a line right down the middle. The first 2 terms have a 2x squared in common. When I pull that out, I leave behind x minus 6. The second 2 terms, x minus 6, well, it doesn't really feel like they have anything in common. And in order for this process to work, we need it to look like the previous problems where we end up with something times a group of parentheses. So in order to make x minus 6 look like something times parentheses, we're just going to pull out a positive 1. When we pull out a 1 though, and we divide x minus 6 by 1, it doesn't change. It's still just x minus 6. So pulling out that 1 essentially does nothing, but it puts it into this format where we can now see x minus 6 is appearing twice. And when I pull this x minus 6 to the front, it's going to leave behind a 2x squared and a positive 1. If you don't pull out that positive 1 though, you might not realize that it's even there. So you might try to pull the x minus 6 to the front and leave nothing behind. So very important we write that positive 1 there to remind us that when we pull the x minus 6 to the front, we still have that plus 1. All right, last one is a you try. So if you haven't paused, please give it a chance. Okay, hopefully you took a shot at it. So we're going to start by drawing a line down the middle. The first 2 terms have a GCF of x squared. So I'm pull that out and leave behind x minus 3. The second two terms have a GCF of 2. I'll pull that out and leave behind an x minus 3 again. I can pull that x minus 3 to the front, which leaves behind an x squared plus 2. And that is how you factor by grouping.